Okay. I'm introducing Bob Dalesio. He's one of the fathers of the EPICS environment. His talk is about EPICS 7, provides major enhancements to the EPICS Toolkit. Bob is with Osprey Distributed Control Systems, and their mission is to support the EPICS community to develop and maintain control and data acquisition systems for world-leading research facilities. So, welcome to Bob.
Hi, it's nice to have you all here. Thank you for coming back from your break on time. I'm usually bad at that, but for those of you who are here, thank you. I'm going to need slides. Here's a very nice picture of Spain and there we go. Thank you. So EPICS 7 provides major enhancements to the EPICS Toolkit. First, I'd like to acknowledge the group of people that have been working on this for years. And in the last 3 years, we've started to have people actually use this to develop services and clients. And so we've made quite a bit of progress in the last 3 years. That's just the outline. So why EPICS 7? We wanted to be able to integrate all of our data into microservices, real-time, processed configuration data. We want to support services for data acquisition, data management, and analysis. You know, we looked at where people were developing applications outside of EPICS, and it was all of these areas, so it was clear we were not serving them properly. We want to continue to provide regular data types so that we can make common clients that work for common things, but now we have the ability to define arbitrary data structures. So you want to create your BPMs, your power supplies, you can have at it. The common clients do not support that at the moment, but you can write things on either side that see it. And we plan to continue to provide these through a robust and high-performance environment. So what it's not a replacement for V3. V3 still works. It does not introduce a new I/O. I renamed the IOC. It's an IOTC now, so it makes it more clear that you can see everything that's in it. EPICS 7 doesn't require you to rewrite all your drivers, and it doesn't break your existing system. So you can load this as your new release. It'll have the latest EPICS v3 and the PV access protocol in it. Just to get to EPICS 7, you have to know what EPICS 3 is. It's a set of tools, libraries, and applications for creating distributed control systems. It's always been that way. The IOCs have always made all of their data available. EPICS 7 extends EPICS 3. It does this by enabling other data stores to expose their data to other devices. It doesn't require upgrading any of your existing applications. EPICS 7 adds structures and RPCs to EPICS 3. So the structured data allows you to extend EPICS from an instrumentation and control to data acquisition, image processing, and beyond. We have efficient network transfer for high-performance archiving and image transfer, RPC-type services for service-oriented architecture like archiver, name server, data indexing. And we can do more complex control because now when we go to an IOC, we're able to take over multiple lock sets and coordinate puts or gets to a set of instrumentation. So the support of structured data, for people who know the interior, this is a standard EPICS scaler. Some small changes. The alarm part now has a string, so you can put an alarm message in it. And the time now has a user tag, so the timestamp is much bigger because we found out people are going to live past 2025. And so you have more space there to do user tags for Pulse ID, and the time will not roll over. So it provides efficient network transfer, right? We've always been about efficiency and performance. So now if you monitor a signal with all of its related metadata, only the things that change will get transferred. So in this case where the timestamp and value are changing, but the alarm condition is not, the only things that go across the wire are the value and the timestamp. We have an RPC type service now. So the RPC service can use structures that are different on every call and the different put request and get response. So PV data now can also encode more complex data types like a table. So now you can go to a relational database and have a configuration table come back. EPICS base status, this is the new build, has EPICS 3 and PV access, all this in a single EPICS 7 release. The PV access and PV data run alongside channel access and DBR types, so there's no disruption to what you have running. We created normative types, and these are PV data structures that represent standard things like all of the existing EPICS types, but also tables, n-dimensional arrays, heterogeneous arrays, tables, things like this. PV access now provides improved metadata. So when you get an array, it gives you all of your access information, any other metadata associated with your detector, for instance. It provides communication to relational databases and SQL databases. And there is a PV access gateway that'll transport this data outside of your control network. And that's running with arrays and tables. Specifically, we did it for area detector data. Other things that'll be finished soon, except for access security, and EPICS record set that takes advantage of this. All this other stuff should be finished by Q2 of 2018. And on the service side, the IOC is running with PV access and the extended metadata. Area detector is available for integrating your beamline instruments. There's a directory service, save sets for save restore, and a data index service to help find your data. And we have 3 other services that should be finished Q2. Unit test and performance tests are provided with most code, and all of this is available through Python, MATLAB, C++, and Java APIs for client and service development. So we have tools that allow you to easily integrate your data as a EPICS 7 service into your network. So standard clients connect to services large and small. So if you use CS Studio or Python client or C++ or Java or MATLAB, you can get to the set of services that are being developed as standards. And again, you can extend this set for whatever data store you have that you want to add to your network. So for instance, this idea of having these services is meant to reduce the physics codes and the data acquisition codes, so that when your scientist or your physicist is sitting there solving their problem, they don't have to recreate all of the common parts of this. They don't have to create a log file or an archiver. They can integrate it into the services that already exist. For feedback control, they can go to the directory service, and instead of knowing all of the EPICS PV names, which are 1 million, 2 million, 3 million, they can use their physics device names and go here and get a list of the process variables that are associated with those devices. They can go to the IOC like they always have and get the readbacks, calculate the errors. They can go to a conversion service and do current to field and field to current and set the output. The script at NSLS2 to do slow feedback control was 5 lines of code where one called the subroutine that inverted the matrix. It's 5 lines of Python and a subroutine to invert the matrix. Everything else was through these services. There was no configuration of PVs to physics names. That was in the directory service. And once they put that in the directory service, every other client that's on the network can use that. So from Control System Studio or a Python application, they could use those same device names, the same physics queries, and get the orbit or get the list of PVs for controlling the beamline. So this is really useful to get this into one service rather than have it embedded in SDDS or MATLAB middle layer toolkit. Oh yeah, sorry, and it also puts an entry in the operator logbook so that everybody can see that the physics application ran and was messing with the control system. Who's using EPICS 7 at this time? ESS is planning to deploy this. They're early in their thing, but they plan to deploy this in a full way. Up till now, NSLS2, FRIB, and RAON have been using middle layer services for the channel finder service, for save sets, for data indexing, and more services are planned now for Q2 of 2018 for archiver, snapshot, data, E-log. The SNS beamlines are implementing next generation of controls and data acquisition with this on their neutron experiments. LCLS in 1 and 2, they re-implemented their high-level physics database access using PV access and the middle layer services. Franz Haber Institute is using the archiver appliance with PV access and structured data. And APS is using the vForce RPC services for their large buffer service. Diamond and NSLS2 are also making big use of this in area detector for doing their beamline data acquisition. Right now, the data transfer from area detector across the network using PV access uses 90% of the physical bandwidth on a 10 gig Ethernet with no compression. So PV access is a very efficient transport of this large data sets. So in conclusion, EPICS 7 enables the integration of all data through microservices. The normative types are there, so if you want a well-defined interface and common clients, you can use the normative types. We have standard microservices for integrating standard data stores like Control System Studio, Archiver. This continues to provide a robust, high-performance network protocol and data interface. The instrumentation continues to be easily configured and integrated. We're not writing code to integrate our data to add signals. And EPICS 7 is in use already for physics applications and data acquisition. What? That's it.
Thank you, Bob. We have some time for a few questions. It's a bit difficult to see, so the people with the mics, can you just see if there's hands going up? There must be a question for the father of EPICS. None?
We had an EPICS meeting earlier. I think maybe everybody asked their questions. So,
thank you, Bob.
Thank you.